where the domain of interest is to you. So with that, if computer science is all about information and with it the solving of problems, well, what does it actually mean to solve a problem? Let's see if we can't propose a model into which all of the lessons learned will ultimately follow. And I'd propose that this is problem solving. You've got some input, which is like the problem you want to solve. The goal is to solve it, so that's the so-called output. And then somewhere in here, the proverbial black box, is some kind of secret sauce that gets the work done. And in the coming months, we'll have to decide, well, how are we going to represent these inputs and outputs? And really, how do we code up? How do we write solutions for what it is that's solving the problem? Of interest to us. So when it comes to representation of information, like there's a lot of ways we can do this. And for instance, if the problem at hand quite simply is to like take attendance at the beginning of class on the first day of school, well, how could we go about doing this? Well, we could actually use a system called unary. Well, what is that? Well, that's a fancy way of saying 1, 2, 3, 4, 5, maybe 6, 7, 8, 9, 10. And I can use my digits, pun intended, on my fingers to actually count everyone up. And eventually you need toes and whatnot if you have to count so high. But unary is a very simple system of using a single symbol, a human finger in this case, to just solve some problem, like counting the number of people in the room. Let's make this slightly more technical for a moment, a little more mathy. That's just called base 1, where the base under which you're operating has one digit in it, like literally a human finger, and maybe multiple such fingers if you need to count higher. But of course, most of you, if not all of you, generally vaguely know that computers use something other than unary, and even you and I probably don't use this that often. They use what language or alphabet instead? Yeah, so binary. So binary is indeed the system that computers somehow use. So in this case, bi implying 2. And so computers have 2 digits, it turns out, at their disposal. And in fact, if you've ever heard the technical term bit, which is like a smaller version of a byte, more on that soon, well, a binary digit is the origin of that term bit, because if you get rid of some of the letters and you're left from binary digit with just bit, thus is a bit. A bit is just a 0 and 1. It's 2 more digits than you might have on your own finger. And of course, it's fewer, though, than you and I have. You and I typically use, as humans, the decimal system. Dec meaning 10, because you and I generally use 0 through 9. So on the one hand, another pun intended, you've got unary. Computers use binary. We humans generally think and talk in terms of decimal. But at the end of the day, these are fundamentally going to be the same thing, which is to say that it's all pretty accessible to us. Even if you're not a computer person, I dare say you're about to be. So what is a bit? Well, a bit then is a 0 or a 1. That is a so-called binary digit. But how do computers only speak in binary? How do they solve problems, represent information using only binary? Well, at the end of the day, if they want to represent 0 and 1, we need to do so physically somehow. And I dare say that maybe the simplest way to think about a bit, a 0 or 1, is like a light bulb. And so by human convention, let's just assume that if you are a computer, be it a laptop, desktop, phone, or the like, and you want to represent the number 0, you know what? You just keep a light switch off. You keep a light bulb off. If by contrast, you're that same computer and you want to represent the number 1, you take that same switch, that same light bulb, and just turn it on. So a light bulb that's on represents a 1, and a light bulb that's off represents a 0. So why is this relevant to computers? Well, at the end of the day, you and I are charging our laptops or phones at night. So there's some like physical resource being replenished there, whether you're on battery or some power cord. And so inside of a computer are just thousands, millions of tiny little switches nowadays. You can think of them metaphorically as light bulbs, but they don't yet actually shine light. But there are tiny, tiny little switches. And those switches, if you've ever heard the term, are just called transistors. So like computers have millions of transistors that can either be flipped on to represent ones or flipped off to represent zeros. And from that very simple mechanism, electricity is there or it's not, a 1 or a 0, computers can actually count obviously from 0 to 1, but it turns out even higher if they use a little more electricity as well. So how might I do this? Well, let me go ahead and propose that I just grab one of our own light bulbs here on stage. This one's off. So for instance, if this were miniaturized inside of your Mac, PC, or phone, this would be a transistor. And indeed, here's the little switch on the bottom. And if your computer wants to represent a 0, it just leaves the switch off, and the light is not shining. If you want to represent a 1, well, now I've counted as high as 1 because the switch is now on. I've grabbed a little electricity. I'm holding on to it inside of the computer. And so now I see that this is a 1. All right, but unfortunately, with just one switch, one light bulb, I can only count from 0 to 1. How do I count out higher, might you think, intuitively? Say again? Yeah, so more light bulbs. So let me do this. Let me just grab something to put these on so I can use a few of them at a time. And let me propose that here, instead of having just one light bulb, let me give myself maybe 3 in total. So all of them are initially off. And if you think of this in miniature form in your mind's eye, this is like a computer with 3 transistors, 3 switches, representing now the number you and I know as 0. Why? They're just all off. So how does a computer go about representing the number 1? Well, it turns on one of these light bulbs. And how does the computer represent